Welcome back. So in the previous video, when we were defining logs, this is what we defined. We say log n to the base a is equals to x is same as a raised to the power of x equals to n. So these two have an identical meaning where n is greater than 0, a is greater than 0, and a is not equals to 1. Right? In this video, we will see why this is true, or this has to be the required conditions for us to solve x. But let's start with a very simple problems. So let's say find value of, okay, so what we see, find value of log 27 to the base 81, log 100 to the base 10, and log 9 root 3 to the base 1 by 3. Right? Let's solve these equations. So let's take this problem. We'll say log 27 is equals to x. So 27 is equals to 81 raised to x. So 27 is what? 3 cube. And 81 is what? 3 raised to the power of 4 x. This implies x is equals to 3 by 4. Let's take this example. Log 100 to the base 10 equals to x. Implies 100 equals to 10 raised to the power of x. Implies, so what is 100? 10 square equals to 10 to the power of x. This implies what? X equals to 2. Right? Let's take this example. So log 9 root 3 to the base of 1 by 3 equals to x. So 9 root 3 equals to 1 by 3 raised to power x. This is what? 3 square. And this is what? 3 raised to power 1 by 2 equals to 1 by 3x. So 3 raised to power of 5 by 2 equals to 3 raised to power of minus x. So implies x equals to minus 5 by 2. Right? So if you've been given any questions on log and you have to find the value of the x, these are some of the ways to calculate x. Right? Now let's take another example. Let's take an interesting example. So let's say if I have to find a value of some value of n base 2 to base 1. Remember we said a is not equals to 1, but let's relax that condition for now and say we need to find this value. Let's say call it x. So this will mean what? N equals to 1 raised to the power of x. Right? So this implies x can be anything. So anything raised to the power of 1 is 1. So this implies n equals to 1 and n equals to 1. Right? There is no one single value of x. The answer of this is always 1. And there is no single value of x which can define this solution. Okay? Because 1 to the power of x is n. There are many such x, and hence we say but a is not equals to 1, otherwise we cannot define what exactly the value of x is, right? So let's say, okay, so this is all, we cannot say n, but what about log n to the base 0, right? So in this case, n is equal to 0 to the power of x. Again, anything to the power of 0 is 0, right? So n is equals to 0 for all x belonging to the real number, right? So again, you cannot define what the value of x is, right? So hence we say a is greater than 0 or a is not equals to 0. Now let's take the third example. Now let's say log of -5 raised to the power of 2. Can you solve this? So what does this mean? 2 raised to the power of x equals to -5, right? Is this feasible? Can x be anything? Can x belongs to R in this case? Can x be belongs to a real number space? And the answer is no, right? So we can't, in this case, x becomes an imaginary number, right? We have said a greater than 0. There's no feasible value on which this is feasible, and n x, and hence we say n has to be greater than 0. Okay, let's take another example. We say log of a base negative n equals to x. So what does this mean? N is a number which is minus 2 raised to power x. So n is any number greater than 0. So let's say n equals to 1. And let's say n equals to 2. So we say 2 equals to minus 2 raised to power x. Can I solve this? No, right? So what are we saying? 2 raised to power 1 by x equals to minus 2. Now we know if I raise to the power of minus 2, if I take x equals to 1, 2, 3, whatever it is, this is a non-solvable identity, right? I can't solve this identity, and hence we say a has to be greater than 0, right? So what we conclude? We say a logarithm is defined by log n, which is a number, to the base a equals to x, which is same as an exponent, where we say a raised to the power of x equals to n, right? And we have seen how to solve questions using this property. However, these two are identical, where n has to be greater than 0, a has to be greater than 0, and a should not be equal to 1. So these three properties needs to be strictly followed for log to be defined. Great. In the next video, we will see some of the properties of logarithms and solve more questions using those properties. Thank you.